1A group elements in the periodic table are called alkali metals. The elements belonging to this group are lithium, sodium, potassium, rubidium, cesium, and francium. Francium is a radioactive element, and the rest all members are considered to be the alkali metals because these compounds oxides, for example Na2O2, when dissolved in water, can give rise to a base. So the bases that dissolve in water are said to be the alkali compounds, and hence they are named as alkali metals. These elements have one electron in their outermost shell, and hence the general configuration is given as Ns1. For lithium, it is atomic number is 3, so the configuration is 1s2, 2s1. There is one electron in the valence shell, that too in s orbital, so we write the configuration as 1s2, 2s1. Similarly for sodium, it is 1s2, 2s2, 2p6, 3s1. So like this, for every element of 1a group, the outermost electron enters into s orbital of next shell. For potassium it is 4s1, for rubidium it is 5s1, for cesium it is 6s1. So the general electronic configuration is given as ns1, where n indicates the principal quantum number or the shell number or shell number, whereas s indicates the subshell and this 1 indicates the valence electrons. Let's know about the physical properties of these metals. So first is the atomic size. Atomic size, or we can also consider it as atomic radius. So generally atoms are spherical in shape. So from center of the nucleus to the outermost shell of an atom is said to be the radius. So these alkali metals have the largest size in the period because these elements are to the extreme left of the periodic table, and as we go from top to bottom, since the number of shells are increasing, number of shells increases, atomic radius also increases. So from top to bottom we observe the electron entering into next shell. Here it is second shell, third shell, fourth shell, fifth shell and sixth shell. So as the number of shells increases from top to bottom, atomic radius also increases. They are the largest sized elements in their own period or shell. Ionization enthalpy is the minimum amount of energy required to remove the electron from the outermost shell of an atom. So if we consider an atom, to remove the last electron present in the valence shell, the minimum amount of energy required is said to be the ionization energy 1. After removing an electron from the metal, it becomes a unipositive cation. The energy required for this process is said to be ionization energy 1, and after removing the first electron, the removal of second electron from the unipositive cation, the energy required is said to be ionization energy 2. Now in case of alkali metals, after removing the first electron, this M plus cation attains a octet configuration. It attains octet stable configuration. So to remove the electron from this M plus configuration, ionization energy needed is very high. So IE2 for alkali metals is very high compared to IE1, and ionization energy is said to be inversely proportional to atomic radius. So as atomic radius increases down the group, ionization energy decreases down the group. Oxidation state is the charge developed by an atom either by loss of electrons or by the gain of electrons. Since the alkali metals have one electron extra in their valence shell, they readily lose this electron and form cation. So the tendency to form the cation is highest in alkali metals, and the oxidation state is said to be equal to +1 for alkali metals. And electropositive nature or metallic nature is nothing but the tendency to lose electrons readily. As they have extra electrons in the outermost shell, they readily lose electron and they readily become cations, and the electropositive nature is very high. So down the group, electropositivity increases and metallic nature also increases with the increase in the atomic radius. Electropositive nature is directly proportional to atomic radius. And next property is the electrical conductivity. 1A group elements or alkali metals are good conductors of electricity because of the free electrons present in the outermost shell, and as they readily convert into cations, they can lose this valence electron readily and show greater electrical conductivity. So down the group, electrical conductance also increases with the increase in the size. So electrical conductivity is directly proportional to atomic radius. Flame coloration is the next property of alkali metals, where alkali metals and their salts impart color to the flame. It's because of their low ionization potential. As we can remove the electrons from their outermost shell very easily, they give out electrons even with the Bunsen burner flame and impart colors by absorbing different energies at different levels. So, these electrons that are excited from the lower energy level to the higher energy level absorb some energy and they come down to the ground state by emitting certain energy in the visible light region. So, hence, lithium shows crimson red color, flame of light. Sodium shows yellow color, flame. Potassium shows violet color. Rubidium shows red violet color, and cesium shows blue color. These are the different flame colors imparted by 1A group elements. And the next property is photoelectric effect. Photoelectric effect is when on the metal plate the sunlight is passed, the energy that is released from the sunlight, if it is equal to the ionization energy of the metal, then the electrons ejected out. This process is said to be photoelectric effect. Cesium being the large sized element, and it has low ionization energy value, cesium can give out electrons readily and is used in the photoelectric cells in the large extent. So cesium is the mostly used element in the photoelectric cells. When a salt is added to the water, it gets hydrated. So, for example, if we consider sodium chloride, when added to the water, it will form Na plus and Cl minus ions, where Na plus ions will be surrounded by water particles, and similarly Cl minus ions also will get surrounded by the water particles. Now these ions that are formed is said to be the hydrated ions. The energy released during this process is said to be the hydration energy. This process is an exothermic process. So if the cation is of smaller size, it will have greater hydration. If the cation is small, then it will have greater hydration. It's because cation with the small size can accommodate more number of water molecules with greater charge, because of which there will be greater hydration. So hydration energy is observed to be decreasing from lithium plus to cesium plus. Hydration energy decreases down the group. Now if you look at the mobility of ions is inversely proportional to the size of hydrated ions. If the size of the hydrated ions increases, mobility decreases. So lithium plus ion hydrated size is greater than that of the cesium plus ion hydrated size. So hence mobility will be greater for cesium plus compared to rubidium plus greater than potassium plus greater than sodium plus greater than lithium plus. This is the mobility of hydrated ion order. Among the all alkali metals, lithium is said to be the strongest reducing agent. This property mainly depends upon the low ionization potential, high ionization potential, and hydration energy. High ionization potential and high ionization hydration energy of lithium is leading to the strong reducing agent. Hydration energy of lithium is said to be sufficiently high to compensate the high ionization energy. So hence lithium is said to be the stronger reducing agent. Reducing nature or reducing character decreases down the group. Decreases down the group.